Well, thank you very much for having me, and thank you for coming on the Friday afternoon before Memorial Day. You're very dedicated. And so I'm just really grateful to be here and be back at Thayer. It's been 10 years, and it's really fun to come back and see how things have changed, but see how some things have stayed the same. Today I'm going to focus a lot on my fellowship in Washington, D.C. and talk about science and policy and how that works on Capitol Hill. So I'm going to talk about how I went from this to this. So that's me in Antarctica doing research on ice cores. And then this is the senator that I worked for in Washington, D.C., Senator Mark Udall. And I worked, as Alex mentioned, for him on energy and natural resource policy. He's on the Senate Energy and Natural Resource Committee. So, you know, I really enjoyed both things that I did. I really enjoyed working on glaciers and ice sheets, but I really enjoyed the world of Capitol Hill too. And so I'm just going to talk about kind of the differences between those worlds. So I had a AAAS Science and Engineering Fellowship. So for those of you that don't know, the goal of AAAS is to put more scientists in the policy arena, in the policy-making process. There's about 200 fellows in the executive branch, and then about 30 fellows go work in either the House or the Senate. And the stated goal of those fellowships is to foster scientifically informed, evidence-based policy and practice. But what I would argue really happens is we fellows learn how it actually works on Capitol Hill and how technical expertise in policymaking actually is used in the legislative process. And so you might have heard about the sausage-making process before, that is lawmaking. So laws are like sausages. It's better not to see them being made. And it is true, our democracy is messy, but it's that way by design. So just quickly to start off, I'm just going to start off with a couple of definitions so we're all on the same page. This isn't going to be a big lesson in science policy, but when I say science, I just mean the systematic pursuit of knowledge. So whether it be physics, electrical engineering, or social science, or psychology, whatever science that you're interested in. And before I went to DC, I kind of lumped politics and policy together and just sort of thought they were the same thing. But I quickly learned that's not true. Politics is competition between groups or individuals for power or leadership, which is basically what a government is. And policy is a course of action that you choose among many alternatives. So quickly, what is science policy? And it kind of breaks down into two main things. Policy for science, which is making decisions about how we do our science, what science do we do, what are we going to fund, how are we going to organize our scientific institutions, how much funding goes to what branch of science, and so what are the outcomes we want from our science. And the other is science for policy, and this is kind of more what people think about when they think about science policy, is how do I take this scientific data or scientific results and bring it to the policymaker and help them make decisions and help them make better policy. So where is science policy made? And don't worry if you can't read all that. In Washington, D.C., it's in sort of three main places. In Congress, most of the science policy gets made in the committees. So committee staff are subject matter experts. They kind of focus on one sort of area of our economy or of our society, and they become really experts at the science, the politics, the history around those issues. And then another area are federal agencies, so NSF, EPA, NASA, NIH, all the alphabet soup that is in DC. There's a lot of science policy made in those agencies, whether by regulation or funding programs. And then the last place is the White House. So there's the Office of Science and Technology Policy in the White House, and then also the Office of Management and Budget. And this is called OMB, and a lot of people don't really think much or know much about OMB, but it's a really powerful agency because they control the money. So they decide where we're going to send different pots of money. And so you need money to do research, so they're de facto doing science policy by deciding where we're going to send the money. So when I first got to Washington, D.C., I was coming from the University of Colorado. I was within academia and had been in academia for 7 or 8 years. And I kind of had a typical view of Congress that a lot of people do from the outside. You know, Congress has really low approval ratings. I think the last one I saw is that Congress has lower approval than Fidel Castro. So that's not good. And my view was thinking that, you know, there's a lot of misuse of science. So I worked a lot on climate change and why aren't we having a climate bill? And everything seemed very inefficient and sort of like they don't use common sense was the outside view. And then when I got there and I became a congressional staffer, I realized, well, there's another side to that, and it's how politicians view academics. And sometimes science and scientists are just viewed as another interest group, but sometimes they're viewed as, you know, having valuable information that you might need, but you just want to get a number. I don't need all the error bars and all the other things that come along with a scientific paper. And so it's kind of a can't live with them, can't live without them attitude where you need the scientists, but you don't like meeting with them because you just get all the science stuff that you don't really need. So I kind of was in the middle of that because I came from science and I understood where scientists were coming from, but I was now a staffer and I needed to make decisions and I needed to choose courses of action, and so, you know, I became like the politicians. And there's a good reason for this culture shock, and it's because we come from different worlds. You know, scientists are very focused on problems and asking why things work the way they do and trying to get at the objective truth. And a lot of scientists like to, you know, work in their lab, and they don't really want to talk to the public too much because they're afraid they'll say something wrong, or and you're thinking very long term. You work on these projects for years and you're trying to really solve a deep problem, whereas policymakers are kind of the opposite of that. They are driven by issues, not problems, and they want to know why they should care about something. And they're interested in public opinions, and they like the public eye. And so they're two very different worlds and different cultures, and so trying to put them together can be tricky. So I'm going to talk a little bit today about the 4 Ps of Congress. So policy, politics, process, and people. And the way I'll go through this is I'll use an example of an issue that I worked on, so I can give you some sort of real-world examples of how these things interact in Congress. But I will save you the suspense and tell you right off the bat that politics always trumps the other 3. So you might have the best idea, and it's a great policy, and you can back it up with lots of data, and you have lots of support for it from other scientists or maybe other interest groups. But if you can't get the politics to line up, you can't move your policy at all. So I love this quote: policy without a politician is a dissertation. And I know I told those students this earlier today. You know, sometimes we have bad opinions, or we see politicians in a bad light because we don't think that they're using common sense, and we don't like what they're doing. But you can't move your policy forward without a good politician. So that's sort of one takeaway from this. So before I get into the 4 Ps, I'll tell you the example that I'm going to use is rare earth elements. So for those of you that don't know, rare earth elements are just a group of elements on the periodic table. And the way that I got involved with this is I went to DC about the fall of 2010. And earlier that summer, there had been this argument between Japan and China over a Japanese fisherman. And a Japanese fisherman may or may not have wandered into Chinese waters, and China, in retaliation, may or may not have stopped exporting rare earth elements to Japan. And so this issue made us in DC realize, oh, maybe we should be paying attention to where we get our basic materials for all the stuff we build. So China produces 97% of the world's supply of rare earth elements. And so we're really dependent on them for these materials. And what if we get into an argument with them? Are they going to stop exporting to us? So that's kind of how this issue got on our radar. And the reason these things are so important is, you know, I've just listed a few uses, but we have them in all our cell phones, your computers. They're in guidance systems for weapons, so the DoD is involved and wants to know what's going on with these materials. They're very important for clean energy, so they're needed for windmills, solar panels, batteries for electric vehicles. So if we were to have our supply of these cut off, there would be many industries in the United States that would be hurt by this. So I started being interested in this issue because I was an earth scientist, so geology, rocks. I, you know, thought minerals were cool. I'd done metallurgy for my undergrad, so mineral processing. So I really came at it from the scientific and engineering sort of focus. But then working on this and meeting with people, I soon realized that there's many, many stakeholders interested in these little rocks, essentially. So the mining industry was very interested in this. You know, they wanted easier access to mining and permitting. The mineral process industry was really interested. About 15 years ago, we actually used to supply most of the rare earth elements to the rest of the world. But since that industry had died down and it all went to China, we've actually lost a lot of know-how in how to process these minerals. And we just don't have the human capital and the human know-how to sort of build up this supply chain again. Obviously, the federal government is interested, so the Department of Energy is interested because of these clean tech applications, the Department of Defense, the Department of Interior, and then obviously the electronics industry and the alternative energy industries want to know, you know, they need to have supplies coming in as they manufacture their products, and so where are they going to get their supply? And then also other issues that I realized that this was really important to the mining workforce and mining safety, and then metal recyclers, so people who recycle metal here and in other parts of the world are also interested in this. And then the environmental community is really interested. They are usually very supportive of clean energy, so they realize we need supplies of these, but they're also usually pretty skittish about new mining and the environmental impacts of mining and new mines, and so it was interesting to see the dynamic there. And then it was even a human rights issue. So mining conditions in the developing world and also metal recycling in the developing world often don't have very good safety records or environmental records. And so, so you can see just this one little thing that I came at from, oh, that's cool, geology, really touches many different policy areas. So I'll start with my first P of policy. And this issue was actually really cool to work on because it was kind of a new issue. And so a lot of people hadn't formed their opinions yet, so I was able to gather a lot of information and really dig into the issue before we chose a course of action. But just identifying what the problem is sometimes not easy. So are we too reliant on other countries for not just rare earth elements, but other materials like lithium or copper? You know, does it matter if we're reliant on China for something and Canada for something and Brazil for something else? You know, is that a problem, or maybe it's not a problem? And how do we define critical materials? What does critical mean? Is it only critical if it's important for defense? Or what about if it's important for other portions of our economy? I mean, I actually had sand and gravel companies coming to me telling me that they were a critical material because you need sand and gravel to build roads and buildings, and you know, you need it for many things. but maybe the supply chain is not vulnerable for sand and gravel. So defining critical was a huge issue. And should the government do anything? I mean, there were folks making the argument, well, you just can let the market take care of it, and we don't need to do anything. But being legislators, of course, we have to have a law or introduce a bill, because that's what you do when you're in the Senate. So we decided to introduce a bill. But so once you kind of identify what your problem is, then you gather information. And I have these in sequential order, but really it's kind of an evolving process. But so once we decided that we were going to address this issue, I had to learn as much as I could about all of those stakeholders and all of those other issues, and how does the supply chain really work for rare earth elements. It's not really traded like gold or silver on a commodities market. It's individual contracts, and so sorting through that and trying to learn about that was part of my job. And so what are the vulnerabilities in the supply chain, and what can we do in Congress to try to help the problem? And so with this gathering information, one thing I really learned in DC is the earlier in the process that you get technical or scientific information, the better. So once a policymaker has taken a position on something, it's very difficult for them to change their mind, because they'll be accused of being a flip-flopper, or it's just politically difficult to change a position on something. So if you want to get scientific data and information to policymakers to really influence policy, you have to do it really early in the process if possible. So again, more on this gathering information. I hear a lot of folks talk about we need to get more information to Congress because they're not making the right decisions. But actually, a staffer in Congress has access to lots of information. There's congressional support offices, so like the Congressional Research Service or the Congressional Budget Office, that are almost like mini universities that are just there to help congressional staffers and give you information. And there's often academic PhD researchers that work there, and all their job is to help Congress. So you can always get information from them. And then you are always meeting with other folks, interest groups, lobbyists, the national academies, individual scientists. So you always are getting lots of information. So there's no shortage of information going to Congress. The big skill is learning how to sift through that information and judge its reliability, what is its source, what is the credibility of the information. So it's really about putting a puzzle together and sifting through this huge pile of information and getting the nuggets of good stuff. So this brings me now to politics and why introduce a bill. So I said we decided to introduce legislation on the rare earth elements. And there's many reasons to introduce a bill. The fourth one, to fix a problem, is what we normally would think of the reason to introduce a bill. There's an issue that we need to solve, and so we'll introduce legislation to fix it. But actually, if you think more politically, there's actually lots of reasons. One is to put a stamp on that. So if you introduce a bill and you're one of the first people to work on that issue, that becomes your issue. And people associate your name with it. So when we were working on this rare earths legislation, we knew a lot of other people were working on it too, because it was kind of up and coming issues. So we wanted to get a bill out first so that my senator's name would be associated with it, and he was the go-to guy for this issue. Another reason to introduce a bill is just to raise attention. So you might not really think that what you're introducing has a chance of passing and becoming law, but if you introduce a bill and you have a press conference and people see that you're working on it, they think, oh, it must be an important issue, and so they start to pay attention more to it. I'm kind of going out of order there, but to win votes, so right before elections, people will introduce message bills to try to get, again, more attention to, to tell their constituents, look, I'm working on this problem, I'm trying to help you vote for me again. And then to respond to a crisis. And some people say that's actually the only time that Congress gets anything done is if there's a crisis to respond to. And those are actually not ideal policymaking situations because then everything is very political and there's really no chance to get good information in the process. You just pick a side and go. So once we had our bill introduced, the politics really began. And the politics is really about your relationships with people. And so considering all the different stakeholders, again, you know, the mining community really was interested in this, and even if their particular company didn't mine rare earth elements, they were still interested in getting easier access to mining, and so they saw this as an opportunity to attach language that would help them. Again, the environmental community had things to say about it. You know, they saw this as an opportunity to put more environmental controls on mining. And so even though I was working on the supply chain issues, all of that comes into this issue and groups can attach things to your bill. And I already mentioned, you know, are sand and gravel really critical materials? So, you know, but you don't want to tell them, no, you're not important because you want their support. And so sort of balancing out, not watering down your policy too much, but adding things so that you can get more support for your legislation. And so in politics, very much you've decided on a course of action, and now it's time to advocate for it. And so your information gathering becomes more of how can I find information that supports my position and supports the path that I've decided to go down. And so you really use data this time now more for marketing. So you say, look, I have this position and all this data backs up what I'm saying. And so it's not really looking for all of the pieces of the puzzle right now. It's looking for what will support my position. And then politics is about compromise. Everybody wants something different there, and so you try to bring in as many people as you can and you know, put things in the legislation that helps them, that will help get their support and helps their constituents. And so as you can imagine, all of that means it's a messy process, which we as scientists don't like that. You know, we don't like irrelevant things getting into what we do, but that's what happens in politics. So the third P is the process. And again, I would say this is the second most important thing, even though I'm talking about it third after politics. If you don't understand the process and you don't know how to work legislation through the House and the Senate, again, you may have the greatest idea, but it's not going to get anywhere. And so the process is just about who does what and when. And so what do committees do? What do the personal offices do in terms of moving legislation and just how a bill becomes law? And it's not the way that we learned in high school where the House introduces a bill, it passes, and then the Senate takes the bill and passes it, and then it goes to the president's office. It doesn't work that way. It's much messier. But so just I'm going to quickly kind of run through what the process, all the things it entails. But so the first thing, obviously, is you introduce your bill. And in the 112th Congress, which is the one that just ended last year, there was over 3,700 bills introduced in the Senate and almost 7,000 bills introduced in the House. So there's a lot of, and this doesn't count all the non-controversial, we're going to name this post office after this guy type bills. So there's all of those sort of continuing resolutions and other issues that have to be dealt with as well. But so these are just legislation that was introduced. And so we introduced our bill, and the first thing that happens is your bill is introduced, or I'm sorry, referred to a committee. And so in the House, a bill will go to every committee that has any jurisdiction over that bill. So for the rare earth element issue, the bill would go to Natural Resources, Energy and Commerce, the House Science Committee, possibly Foreign Affairs. And so the bill kind of gets worked over by all these committees, whereas in the Senate, it just goes to the Committee of Primary Jurisdiction. And so it's really important to write your legislative language so that it goes to the committee that you want. So because my boss worked on energy and natural resources, I wanted it to go to that committee. Otherwise, we wouldn't work on it. So we'd introduce this bill and then someone else would work on it. And so the parliamentarian is the person that makes that decision. But so you have to, you know, the rare earth elements issue covered so many different things, you know, trade, economic markets, manufacturing. I had to make sure I wrote my language so that it would go to the Senate Energy and Natural Resource Committee, which it did. So after it goes to the committee, you have hearings and you have markups, and a lot of bills die in committee. So a lot of bills go to the committee and just never come out. Either the committee chairman doesn't care about the issue and doesn't want to work on it, or maybe you have hearings on it, but you never get a markup. So our bill got hearings, and then that was it. So never got a markup, and not because of the merits of the bill, because actually both sides were interested in this issue, but there was an offshore drilling bill that the Democrats and the Republicans could not agree on, and so whenever we would have a markup or we would mark up bills, the Republicans would always bring up this offshore drilling bill that the Democrats didn't agree with, and so we could never get to our bill because it was always, everything broke down at this other bill that had been further up in line in the process. So your legislation is very much kind of at the whim of other things that are happening, and so if you're lucky, though, the committee will report out the bill. They'll vote yes for it, and then it goes to the calendar. And the leadership calendar is another place where a lot of bills die, especially in the Senate. The Senate floor time is extremely valuable, and so the majority leader, who's currently Harry Reid, he won't bring a bill to the floor unless it has some hope of passing, and if the president has not threatened to veto it, and if the House is working on something similar. So a lot of things have to happen for your bill to make it to the Senate floor. And since ours didn't even get out of committee, it didn't obviously go to the Senate floor. But the only other kind of bills that make it to the floor are often messaging bills. So you're forcing people to take votes on issues before elections. And so Senate floor time is really... it's really hard to come by because of the filibuster and because of procedure on the Senate floor. So if you're lucky enough to get it on the floor, you have agreements about how it will be managed on the floor, and once the bill gets to the floor, people get to give speeches, people get to add amendments, and hopefully it passes in the Senate, and then all of that has to happen in the House as well. But especially when you're in a divided government, whatever the House is working on this issue, so there were several rare earth element bills in the House, probably look completely different from what we had in the Senate. So then you go to number 7 there, which is the conference committee, where you have House and Senate people try to compromise on the language, because whatever goes to the president has to look exactly the same from both houses. And so then hopefully they come up with a compromise, and the bill gets signed into law by the president. So in the 112th Congress, only 219 bills passed or became law. So that was just a little over 2% of all those bills that were introduced actually made it through this huge, long process. And again, if it's vetoed, it would have to go back to the House or the Senate. But the big thing is, if you don't make it through this huge process by the end of one Congress, which is 2 years, the clock resets and you have to go back to the beginning, and you have to start all over again, introducing your bill, getting it through the committee, working through all the politics. So there's many bills out there that have been introduced every Congress. And there was a story that the health care bill that actually passed a few years ago, I believe it was Representative John Dingell from Michigan, introduced some version of that bill every Congress for 40 years or something like that. So there's a lot of these bills aren't new. They're just reintroduced, but some of them are new, which is what I got to work on, which was pretty cool. Okay. So this is just another little graph. I'm giving a talk at an engineering school. I had to have one graph in my presentation. So this is laws passed by Congress since 1948, and you can see it going way down at the end there. There's the 112th Congress with only 219 bills passed. And there was a lot of news in the press about it being the most unproductive Congress ever. I don't know if that's really true in terms of percentage, but... So after all that, now you know why it's hard to get anything done. And really, you know, this picture is meant to show you look for whatever legislation is moving and try to get your issue on. So you try to get on the train that's moving because there's some legislation that has to pass. Defense authorization always has to pass. And it used to be the budget always had to pass. That doesn't happen so much anymore because people try to pile on their issues. And so you try to keep enough others off the train because you can sink something if you add too much stuff to it, which again keeps happening with the budget. And so it's really important to make friends. This is where the fourth P, people, come in. You really have to build relationships, and across the aisle, you know, people talk about being bipartisan a lot, but it's really important because, especially in the Senate, all it takes is one senator to stop whatever you're doing. And so you really need to get as much support as you can and try to compromise, even though that's kind of become a dirty word now to some people. You really need that support to move through this huge process. So now, what are the roles for scientists in all this? You probably wonder, well, I don't know the three Ps very well. But I would say there are very important roles for scientists. The first is kind of obvious. The one we think of most is to provide data. So when I was working on the rare earths issue, I talked to a lot of geologists, folks at USGS. They do a mineral report every year, so where are the minerals coming from, who's selling what. And so they just gave me good data, good background information. I met with universities on mining education. So right after I left Michigan Tech, they kind of moved around and sort of folded their mining engineering into another department because nobody was wanting to major in mining engineering. It just wasn't popular anymore. And so they were coming to me to say, we just don't have the expertise anymore to do this mining and mineral processing in the United States. So yeah, just good data on sort of the background is one way that scientists can engage. The next one is the honest broker. And this is really a tricky thing to do, but if you do it well, you can be very influential. And so being an honest broker just means you are taking the scientific information and formulating policy options and kind of laying it out there for the decision maker and saying, you know, if you take this course of action, then this is a likely outcome. And so you have to do a lot of analysis and work to do this, but if you are good at it and staffers realize it, then staff will come to rely on you, and you can be very influential. And this role is usually a committee of people because it just takes a lot of work, and people don't really usually believe that one scientist can be completely unbiased. And so if you have a committee of people, you know, they feel better about the honest broker and trusting that you're laying out all the options. A third role for a scientist would be an issue advocate. So this is where you pick a policy that you think that your elected official should support and going to them and saying, this is what you should do and this is why. And this is the technical information that backs up why I think that. And so this is another perfectly valid role for a scientist. You have to be careful in this role though, because if you have to carefully delineate and express when you're being an advocate and when you're being a scientist. Because if you let the two mix too much, people will start seeing you only as an advocate and they won't trust your science as being unbiased anymore. And so you're thinking, well, I'm kind of interested in this policy, but I don't know if I can do it. And actually, I think scientists have a lot of good skills that they can take either to interface with a policymaker or become one themselves. And so we're very good at taking, again, a lot of information and boiling it down into what are the key pieces of information that drive this system. And we're good at suspending judgment and figuring something out before we decide, oh, it's this or it's that. And so I think scientists are really good at that piece of policy making. And so I just, I have kind of a list here. So, and we write a lot, and as a policymaker, you write a lot. You write different types of things, but you do write a lot. And public speaking, again, you go to conferences and talk to people, and so you can kind of boil down your science to someone who doesn't necessarily work in your field. Well, you do that as a policymaker. You take these complex policy issues and kind of boil them down for the public. And so, do you need to do policy relevant research? So, does looking at ice cores really help me to work in Congress or digging a snow pit in Greenland? That specifically, no, but learning how to think critically and solve problems really does help. So doing policy relevant research is helpful but not necessary. So you can still engage in this process even if you work on something that maybe isn't big in politics today, but maybe it will be in the future. But you still have the ability to engage the process. And in Congress, they don't know how narrow your focus is. So when I worked in the Senate, if anything technical came across the desk of my boss, they would say, oh, you're a scientist, here, you deal with it. Because even though I didn't know anything about neuroscience or anything, they just figured, well, it's science-y, so you can do it. And it's true, I could at least, I knew where to find out, okay, who are the key players in this scientific field, and then go talk to them, and what questions do I ask them, and how do I get the best information. So you have value in that you are familiar with the scientific community and you know how they work and what's important to them. And even policy relevant research is not that relevant. So, I was counting layers here on an ice core, which is important for climate change, but really climate change when you go to DC is more of an economic issue and human rights issue and security issue. It covers much more than just what's happening in Antarctica. So as I come to near the end here, how do you talk to your congressional office? So if you want to talk to your House member or your senator, I think that you should if you want to, because especially if you're a constituent, they want to hear from you, they want to know what you're thinking and what you're working on. And so it's always good to go talk to them and just develop a relationship, but there are some important rules. So staffers are busy, and you have one shot to make a good impression. So you have to get their interest right away. So you'll have a meeting with them, maybe 15 minutes, maybe a half hour, but you have to get their interest and why they should care within the first minute or two. So I don't know some people call it an elevator speech. If you get in the elevator and Barack Obama's standing there, what are you going to say to him about what you do as you go from the second floor to the fifth floor? So you have to be able to boil down your issue into something that you can say in a few sentences. So you don't need to give them every detail. And as scientists, we love all the details and all the in the weeds, and we love to talk about all that. But staffers don't need to know that yet. If they need to know something, they'll ask you, but you really need to just sort of give them the quick and dirty at the beginning. So before you meet with someone, do your homework. Who are they, and what is their background, and what does their boss, the senator or the representative, what does he care about? What has he worked on in the past? What are his voters like? What do his voters care about? Because if you can relate something to the voters in their district, that's really powerful. They want to know that. So why should their boss care? And then have an ask. which means you have to tell them right up front why you're there. And as scientists, we don't like to have an ask, or at least for me, it was uncomfortable at first. It's like, I have all these cool results. Shouldn't you just be interested in seeing the cool results? But no, you need to have a reason that they need to know this, or a reason that you're there. And it can be, we want more funding for science. That's a perfectly good ask. Or we want you to support this legislation. Or so have a reason and an ask, something that you want them to do, because that's what they want to know right away, is why are you there? And this happened to me very quickly. Even as a scientist, when I would meet with people, I would want to know right away, okay, what do you want from me? How can I help you? Because if you don't tell them that, and then you leave, and then that staffer has 5 more meetings that day, you know, your stuff gets to the bottom of the pile. And if you don't have sort of an action item or an ask for them, you just kind of stay at the bottom of the pile, because the pile keeps growing and growing. And then if you do meet with someone, consider a 1-page memo. I wrote tons and tons of 1-page memos when I worked in the senator's office. And that's kind of like what everyone, how they communicate their 1-page memos. And we're used to writing 15-page proposals for research, and we pack them with data, and we pack them with figures, and you make the font really small, and you have no white space in there because you're trying to get as much information as you can into this 15-page limit, or whatever the limit is. But on your 1-page memo, you want tons of white space, bullets, you know, only a page, because nobody's going to look at the second page. Just, you know, boom, 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 talking about the history and the politics, who will be for, who will be against it, why they should care. So writing the 1-page memo is actually quite an art form, but if you can get good at it, it's powerful, it's useful. So once you have your meeting and you talk to them and you build your relationship, if you really want to continue to be effective and engage in the process, you have to establish that relationship. You have to establish trust. And so, like I said, make your intentions clear. They want to know why you're there. And it doesn't matter why, they just want to know why. And everyone has an agenda. So everyone's coming to you as a staffer wants something. So they want to know what your agenda is. And it's not a bad thing to have an agenda. They just want to know what it is. And then have your facts straight, because if you, if you provide really good, credible information, then you'll be relied upon. That staffer will later maybe, need to write a memo, 1-page memo on something, and they'll say, oh, I remember Joe, he had good information on this, and they'll come back to you. And make a trip to DC if you can. It's always good to have face-to-face contact, and it helps them remember you more. And never point out a problem without proposing a solution. Everyone does this. We all do it, right? We say, oh, that's a stupid idea. Congress is, I don't know why they're doing that. Well, everyone says that to you. So if you actually can provide a solution, then you're different, and people, again, will go back to you. So, it could be, again, we need to fund more of this, or how about if we change this language to something else in this legislation, or even providing talking points or help with, data for a speech or something. Just providing a solution is really helpful, because staffers are always told, oh, that's a bad idea. And then be available and be responsive. And often, and this was really hard for me to learn when I got there, is somebody asks you a question, and you want to go and research it for a couple weeks and make sure you have all the right answers and you don't give something wrong. But the staffer probably needs it in maybe by the end of the day, maybe in a couple hours, because they realize the boss is giving a speech on X tomorrow. And so, oh my goodness, I need to learn as much about it as I can. So if you go away for 2 weeks and try and learn as much as you can and come back to the staffer, well, they don't need it anymore. And so it's always better to give, less information in a timely manner than the whole story 5 days later, because it's just not going to be used. And that's hard for us as scientists, because you want to make sure you get it right, but sometimes you just have to go with what you have. And find common ground as you build relationships and network, as you build relationships with staffers and other people in DC. Really, all about who you know, and you know, as you talk to people and learn about what they do, and you can sort of learn about opportunities that you didn't even know existed before, and you can it just helps you, and as you move through your career, and you can explore different areas that you know you maybe wouldn't have thought of before, but you met with a staffer and they talked about some need that they have, and you realize, oh, I could help with that. And so just talking to people and getting out of your lab and meeting with people is really helpful as you engage in the process. So that's it for me today. This is a big thank you for all of you for having me, and also to my advisor, Mary Albert, who's there in the front. This is probably 10 or 11 years ago in Greenland with me and another student, and she's always been very helpful and given excellent advice. And so I did really enjoy my time in Snow Pits, and I really enjoy my time in Congress too. So, so that's it. If you have any questions, please let me know.
Would you think it is worth going through all the laborious process that you go through in light of the fact that many in Congress just don't give a They haven't set their minds on something, and climate change is a very obvious case, and they actively prevent correct information from being disseminated?
Well, I wouldn't say they prevent information from being, they may try, but it gets there. There's so much information that gets to staffers. So it's about what they do with that information afterwards. And it's very worth engaging still, because like I said, you know, right now, climate change is, it's not so much anymore, but when I was there, very much the third rail of politics. You just don't deal with it because the politics were too especially during an election year, too dangerous to even go there. But like I said, with the health care bill, you know, these bills are reintroduced every year, and issues, just because they're not in the press in the forefront, they're still being worked on. And so, you know, I mentioned you need to get scientific information in there early. Well, another opportunity is kind of when an issue is on the back burner and percolating, and there's no really press coverage, and you know, it's still there, but there's not a lot of politics going on. You can get information in and start tweaking policy to make it better. So you can't get someone to completely flip their position, but you can maybe slowly bring people in and, you know, tweak things with better information. So, you know, and then you just wait for your opportunity. You wait for your moving train, and then you jump on when you can. So it's not ideal, but.
There is a popular perception out there that because of the way politicians get reelected is through expensive campaigns and donations in order for those campaigns to operate, that their decisions are being based on the function of whose hand is on their shoulder. Based on your empirical observations, do you think this is true?
Well, it is true that they have to spend a lot of their time working on their next election. And even though the Senate was set up to be, you know, every 6 years, so they didn't have to worry so much about their next election, they could work on issues. With the news cycle the way it is now, that's not the case anymore. So they have to spend time raising money. So there is that piece to it, but what the voters think is always very important to them. So no matter, you know, this depends on how, you know, educated your voters are, but we always had to listen to what the voters thought in Colorado, and we had to make sure that we were doing what they wanted. Now that's tricky because some group wants this and another group wants that, and you can't please everyone. But it is still very important what the voters think because they're the voters. So, you know, the fundraising and the campaigning is a big part of their job, but it's also still, you know, what the voters think, because they can become unhappy and, you know, or they can be happy and support you. And so it's, you know, concern about money in politics, and rightly so, but there still is very much listening to what the mood is of the voters.
So do you think it's possible to remove money from the whole system? And if so, would it be effective?
I don't think it's possible, actually. Would it be effective? I don't actually know, because you still would have, it's a right of ours to go to our government and lobby our government. And so whether that's with words or with money, there is a legitimate argument to be had. But you would still have people of power speaking to your elected officials. So, I'm not enough of a campaign historian to know how much it would affect campaigns, but I still think you're dealing with, people of power who want something and are asking for it versus the general public. And both are important and both are listened to. But I don't think you'll ever get money out of politics, much as we think that would be good. I don't think it'll happen. But maybe I'm too cynical.
Thank you so much for that. It was a really helpful and clear way, as scientists, like policy and politics for scientists, really great. So thanks for that intro. I really, you mentioned issue advocacy from scientists, and I was wondering from your perspective, like how the Jim Hansen example of how he's taken his career as a chief scientist at NASA and then also entered the advocacy arena, and
Right.
how do you delineate those roles that you science?
It's very tricky, right? And he has a complicating issue in that he was a government scientist. So he wasn't just an academic, he worked for NASA, so people view that as my tax dollars pay for him. And so that adds another layer of complexity. I think he's actually, whenever I would see him speak, he would always say, this is me personally being an advocate, this is not NASA or the government's. So that's good, because you need to say, what is it? Are you being an advocate or are you being a scientist? And ideally, you would want to keep them separate, but it doesn't work that way in practice. And I think for people who maybe advocate once or twice, you can still keep yourself as an objective scientist. But when you advocate all the time and you get a lot of press and your personality or persona is known as this advocate, then your science is always suspect at some point. Whether it's right or not, I don't think it's easy. I don't know how you find that path. I mean, maybe it's possible, but I know just for me, even when a scientist would come and talk to me, and I am a scientist, so I understand where they're coming from, I always wanted to know what is their agenda. Whoever came and talked to me, I just want to know, so that way I can know how to gauge the information you gave me and who's going to like it, who's going to agree with it, who's going to disagree with it. So you're always trying to figure that out in your mind. So if you know someone is really strongly advocating for something all the time and their science really directly relates to that, it becomes messy. And so, I think what he did, where he said, okay, I'm going to be an advocate now, was actually probably, I think that was brave and probably a good thing. He realized, I'm so associated with this, I'm just going to use my power to advocate instead of trying to provide scientific data. So it's kind of a messy answer, but that's a really tricky issue, is the issue advocate and still being viewed as an objective scientist.
You mentioned earlier engineer getting into policy making better, and I was wondering, how do you seek out the valuable technology in the early stage, when they are not so popular before you get into the public?
How to get the information?
How do you find out the new technology that could attract the politicians' attention?
Oh, I see. Well, you know, as I mentioned, you know, so a lot of the work as a staffer is what's going to happen this week and how to support your boss. But you always have kind of in the background percolating things that you're thinking about and people that you're meeting with. And so a lot of times it'll be companies in your district that maybe have a cool new invention or a new way of, you know, some innovation. And those are some of my favorite meetings, is when people would come and say, look, I have this really cool new engine for a cleaner engine for buses or something. And so you kind of hear about it that way, and then they are trying to get, you know, maybe a DOE grant or something like that, where you know, it's not so much the politics of the day, but it's something that you can sort of help out with. You can help them as they, you know, try to get funding to do more research or development for a product. And so I think a lot of times you learn about it just from meeting with constituents or people in your state. And so I maybe wouldn't have heard about other technologies in another state, but I've heard about this one, and then I take it on and say, hey, I go to the Energy Committee, and have you heard of this company? They are working on this cool technology. And then if you have, say, like a hearing or something in your committee about that, then maybe you ask them to come and testify and be witnesses at the hearing. And so it's kind of, you just kind of learn about things as you meet with people, new technologies and new science.
As I know, there are three major powers. One is G77, and the other is the umbrella group, and the other is the European Union. But since the congresses of the parties, they have been negotiating for years, for decades, but it seems like no real agreement has been reached. So I wonder, what's your opinion about the outcomes of such
climate treaties? Well, I didn't work I didn't really work on much on climate or diplomacy, but I think what I would say about that is people call climate a wicked problem, meaning we probably won't ever find a perfect solution. We just have to muddle through as best we can. And so I think that climate is a perfect example of having so many different stakeholders in each country, and then each country, then you add all the different countries. And so trying to make everyone happy is really difficult. And so, you know, people like to argue about climate science, but I think what we really need to be discussing is all of the other implications. So development in the developing world, and economic questions, and human rights, and all the other pieces of the puzzle that really result from climate change. But they're hard questions about their value judgments and their values arguments that we need to have, and it's hard to have values arguments, so it's easier to argue about science. And so I think that's kind of what happens, is we just argue about science instead of our value judgments, because it's stickier to do that. So that's my uneducated opinion, but oh.
What did you think about House of Cards?
I've never seen it.
Not seen it?
No, sorry. I know it exists, but I have not seen it.
I'll take one last question.
Yeah. Well, what do you think will be the career paths for people with a science or engineering background and you know, want more influence in policymaking? Because you mentioned most of them were just like providing advice and trying to get the view into the system. So do you see any like typical career paths for people with science or engineering degrees and desire to have much more influence?
Mm-hmm. Well, you know, one is these fellowships. They're a really great way to get to DC, and I really think, if at all possible, if you're interested in moving more in the policy direction for a career and not just influencing the process, spending some time working in DC is really valuable, because inside the Beltway, they call it, is weird. You know, it's weird. We all think, what are they doing in there? It's a strange environment, but it's really important to learn how it works in there and how all the different people, whether they're in the agencies or in Congress, what expectations do they have upon them, and what pressures do they have, and you know, just kind of learning how all the pieces fit together. It's really important to spend time in DC if you can. And you don't have to stay there because not everybody likes to live there, but that's really helpful. But another way that I've seen people do it is if you work for a government agency, so say the EPA or the Department of Defense, as a scientist, you know, you might start off as a scientist there, but then there's opportunities throughout that agency to maybe move more in the policy direction and get more decision-making authority, and so that's another way too. It might take longer because you know you're really viewed as a scientist and you have to slowly move your way towards policy, but yeah, I mean, I would just encourage you to just keep engaging in things that interest you about policy, and you'll find opportunities to engage in the process. And then as you do that more and people realize that you might be someone to go to for policy relevant science, you know, then you would learn about other opportunities. And so there's not kind of one easy answer to that, but you know, there's many different ways that you can go.
If there are more questions, I'll invite you to meet with Ursula. Thank you very much.
Thank you.